Welcome back to Precalculus. The example that I briefly mentioned in the last video, where A is 49 degrees, B is 42, side length B, side length C is 15, we're going to do now, as well as one additional example. This problem is a great candidate for law of cosines because we don't have a known column. We can't quickly get one. You know, like when you have two angles and a side, you can always get the third angle in a triangle, and then you have a known column. But we don't have one angle or even no angles. No angles, you always need law of cosines. But with one angle, and it's not opposite one of the known sides, you have to use law of cosines. So which version would be most appropriate? Well, I have angle A, so I want to use angle A. Remember, angle A is at the end. And if I'm going to have an angle A, then it's the same letter as the letter at the start. So let's do this with this formula. I'm going to write the formula out, which is probably a good idea. It starts out looking like the Pythagorean theorem, but then you have the minus 2, and then the last two letters are repeated there without squares, and then a cosine. If you want to put a dot there, it's kind of confusing with all the C's back to back there. Cosine of the angle A. Okay, so when we plug in, we don't know what A squared is. This is the easier one to simplify. The harder ones most people think is when the angle's unknown. So that's 42. This is 15. Another 42, another 15. Cosine of 49 degrees. This is really nice to put in your calculator. You can put the square root in the beginning if you want. I always forget to do that. So I just usually end up doing 42 squared plus 15 squared. I know you can't see this, but minus 2 times 42 times 15, cosine of 49. Make sure you're in degrees, and you should get 1,162.365, blah, blah, blah. I don't think it's really worth writing that number down. I'm just going to immediately square root it. And when I square root, I go square root second answer, or if you were thinking in advance, you could just square root of the original number, of course. But you should get, I'd like you to try this in your calculator yourself, 34.09348. We're always going to round our answers to 2 decimal places. 1 down, right? To solve a triangle, we need to find the other 3 parts. So now what? Now we have a known column. I wouldn't keep doing law of cosines. I would go over to law of sines now. So using our known column, we can now say sine of 49 degrees over this 34.09. I'm going to do this. I'm going to store this in for x. I'm not picking A because it's always capital A, and put that there. You can use second answer if you want, but this just get in the habit of not using rounding values might make it more clear. So you can either find, okay, here's a big moment here. You can find angle B or angle C next. It probably doesn't even matter, right, which one you find. Actually, it might sometimes, and I think this is a problem. I tried to design it where it would. I don't remember what would happen if I didn't do it. Maybe I'll try that. But here's a rule of thumb. Maybe I'll write this out in red here. Always use law of cosines. Let's say law of sines. I'll do the cosine statement in a moment. Always use law of sines to find the smallest angle. I guess I'll say remaining. Smallest, that is so important. Here's the thing. If you went and found angle B, remember when you use the arc sign, the inverse sine button, it always assumes the angle is acute. But what if it's obtuse? Law of sines won't find obtuse angles. You could manually find it like we did in the ambiguous case, but which one is right? These are only going to have one solution. So find the smallest angle first because you know it's acute, right? If there's a obtuse angle, it's the only obtuse angle in that triangle, right? A triangle can't have more than one obtuse angle. So if there's an obtuse angle, there's only one. If there's a right angle, there's only one. And there can't be a right and obtuse. So I know the angle opposite 15, it has to be smaller than the angle opposite B. And that means if there happens to be an obtuse or right angle, or obtuse or a right angle, it must be opposite B. So we don't want to get involved with that with our sine. So do sine of C next. Whoops. Sine of C next. And then, you multiply both sides, or you can cross multiply if you want, or I don't have that much room, so I'm going to go here. You should get to this point. 15 sine 49 degrees over this x. And again, this is my notation of saying, hey, I stored this in my calculator as x. You don't really have to. You could just use second answer. Although if you're going to be doing some extra things, you might want to use it later. So 15 sine 49, close that parentheses, divided by x, or second answer. I stored it as x, so I'll put x, and I get 0.33. You don't really have to write this down, 3320, and it goes on, but I'll say now second sine, second answer. It gives me an acute angle, but I know it has to be acute, 19.39 degrees. So when you're using law of sines, find the smallest angle remaining. You know what? We'll address law of cosines in a moment, but there will be a law of cosines statement coming up. Once you get that, what's left here? All we have left is angle B, and what do you know? It is obtuse. So if I had done it the other way, so let's just see. There's angle A, there's angle C. So angle B would be, I'll just kind of go here. We could do on your calculators, you can say 180 minus second answer, which second answer is the 19.39, or you can put in 19.39 in this case because you're not multiplying it, minus 49, and I get 111.61 degrees. So I have three boxed answers, 1, 2, and 3. By 3, that's solving the triangle. So finding the smallest angle available or remaining is the way to go with law of sines. Okay, let's do another example, and this will create our second key rule here. Our next example is, let's say we have little a is 31, side B is 52, and side C is 28. This is a fascinating example. Really, I mean, any geometry student would wonder, is it possible to have three sides of a triangle and find the angles? I mean, yeah, if it's 3, 4, 5, yeah, it's a right triangle, and then you could use arctangent. But if you don't know it's a right triangle, if they don't make up a Pythagorean triple, is it possible? And it is, right here with law of cosines. So I have a decision to make. I have all three sides. So if you think about let's look at the formula here. If you have all three sides, you can actually do any of the three forms of law of cosines. It just depends on what angle you want to find first. We can find any of them. Well, with law of cosines, when you have a choice to be made, find the biggest angle first. You could get away with not doing it that way, but I would advise it because if there's an obtuse angle, it will find it. I hate to get back in the weeds of this, but fast forward this if you want, I guess. Remember the cosine graph looks like this, right? And when we made that decision about restricting the domain of where we would restrict the domain of cosine so that it has an inverse, it was decided, and many of us were annoyed by this because it causes issues and some other things. Although it causes good stuff, like in this case, it's really good. We decided to restrict it from 0 to pi. In that region, cosine hits every value in its range once and only once. So it's a good choice. It also includes the first quadrant. We like that, good choice. But it includes the second quadrant, which is different than how sine and tangent are, because their negatives are picked up in the fourth quadrant. That's a discussion for another day. But anyway, because of this fact, when you do second cosine of a ratio, if the ratio is negative, it's going to give you a second quadrant angle, which is obtuse. It's between 90 and 180. So what that means is our cosine can distinguish between acute and obtuse, while sine cannot. It always, your calculator is always going to assume acute. So with this in mind, we can make the decision to let cosine, as much as possible, deal with the obtuse angles. So our lesson here, I'll go ahead and write my second one. Always, always use law of sines. I don't know, I might say this. Always find, I think this makes more sense. You might rearrange the previous statement. Always find the largest remaining angle with law of cosines. I think that statement makes more sense to put it in that order. But anyway, just a kind of a grammar thing. So law of cosines, pick the biggest. Law of sines, pick the smallest. You often won't have a choice. And if you don't have a choice, do what you can do. Like in law of sines, we rarely have a choice. We just do what's available, and that's where the ambiguous case comes up. Okay, so let's do this one. So we're going to find which angle first? Angle B. That's right. Hopefully that's what you said. So I will start. I'm going to, again, you don't have to do this, but just good practice writing this out. Whoops, not equals. Yeah, that works. Good practice writing this out. Is that on? Yeah. Times cosine of B. So these letters, again, are repeated there, and that is always the same as that. It's kind of a mirror image, really. If you switch the C and the A there, it really would be a mirror image, but that'd just be weird. Okay, so we can plug in. This is 52 squared. This is 31 squared. This is 28 squared. Is there anything we don't know? This is 31. This is 28. Cosine, here's our unknown, right? Every equation, we want to have one unknown to be able to solve it. And students often have difficulty solving for B here. The book, I'm not even going to show it to you. You can look it up if you want, or Google it or something. Law of cosines, solve for angle. You'll see these formulas. But to me, those are formulas for people who can't do algebra. If you can rearrange a statement, okay, there's some weird things. You don't need that formula. But there's always a large percentage of my students that like it. So I won't give you a hard time if you use it. That's fine. But I just figure I can do a little bit of algebra. I can solve for it. So I'm going to show you the process, the steps I use, but ultimately I will do all this on my calculator, and I'd be fine if you did the same. So in green here, these are things that aren't really required. You're going to first subtract the 31 squared and the 28 squared. And then this negative is still there. That is one of the things that people have trouble with. Now, if you go on and take calculus, let me just tell you, there is lots of complex algebra. You're going to have to be able to keep track of signs like this. So you could put that in your calculator. I guess I'll go ahead and do that real quick. 52 squared minus 31 squared minus 28 squared. And that is 959. I'm just going to do this. 959. Then what? Well, this reminds me of doing a problem like this. You know, back in the old days, you're doing a problem like 15 equals 3x. That's basically what we have. Oh, come on. 3x. You have a number equaling something times the variable, right? I know it's got a cosine, but anyway, you divide by 3, right? So we will take this and do 959 over negative 2 times 31 times 28. That's going to equal cosine of B. And then I guess you can figure that out. It's this. I don't like this because I'm going to write out a decimal. I'm not going to simplify that. Then we inverse cosine. I'm just going to switch the order just so it looks a little nicer. Of whatever this is. And notice, is this number going to be positive or negative? Negative. You don't need to do anything in your head to figure that out. The numerator is positive. The denominator is the product of three numbers. One of them is negative. That's going to be a negative number. Positive over negative is a negative. So this is going to be a obtuse angle. Whew. I'm glad we did law of cosines first. If we done law of cosines with B, if we did law of cosines with A, we'd have got an acute angle. And if we did law of sines with B, we'd have got another acute angle, and our C would have been wrong. One way around that you could do is you could just do law of cosines 2 times. But I usually just want to do it once per problem. Okay, now I'll put this in my calculator. Divided by parentheses, -2 times 31 times 28. So make sure all of that is in parentheses. Enter. And then second cosine. And this is something you have to practice. Okay, so make sure you're practicing this. 123.53 degrees. And I'm going to store that in as X or B, whatever you want to go with. I'm just going to go with X again. I don't know. You could do B. I don't want to confuse it with a side B, but whatever. But you got to practice this. Now I'll tell you what I do and what I will demand of you. You must show this step, and you must show this step. That's all. Set up, answer. Everything else really can be, do it on your calculator. I don't need to see all that. It makes these problems really annoying, actually, when you're doing all that without your calculator. So when you do that, you feel like you're thinking more and not just computing. Let your calculator do the work. If you have issues, feel free to write out as much as you want. Okay, to wrap this problem up and probably wrap this video up, I'm going to find the other 3 angles. Once I get an angle, I like to use my law of sines. So we have a known column. So we have, let's switch up the color here to red. So sine of that angle B, which for some reason I'm calling X, over B, this is why I called it X, I don't want to confuse it with this B, over 52 equals, so which angle to find next? Well, I said always find the smaller one next. There's not really danger of angle A or C being obtuse, but I'm just going to follow the rule and find C next. It wouldn't matter if you didn't. Okay, do that. So sine of C is 28 sine of that over 52. Put that in your calculator. 28 sine of that value divided by 52. Make sure you close your parenthesis after the angle X or angle B, whatever you're calling it. And I get 0.44. I'm not going to write that down. Well, why not? You don't need to write this down, though. Really, just writing down numbers that you're rounding that aren't final answers don't make a lot of sense. So second sine, second answer, and I get C is 26.67 when rounded. Now I'm glad I stored this B in. Well, I guess it doesn't matter because we're not multiplying. So I will do 180 minus that second answer, angle I just found, minus my X. And I get, oops, I made a mistake there. Let's try that again. $123.53. Okay, should be, okay, I keep messing this up. One more try. 180 minus 123. This is why stowing is nice. I decided not to stow it. Okay, how about 29.80 is angle A? And if you want to check it, you could always add them back together, see if they equal 180. That looks pretty good to me. Okay, well, I think we're going to stop this video there. Hope that was helpful. We'll have a short one to finish off section 6.2 with an area formula called Herons Area